They will meet twice. If the time interval between these two meetings is delta t, find an expression for initial separation. So what are the some keywords are there? Their initial velocities are u1 and u2. They're subjected to accelerations opposite to their initial velocities. They'll meet twice. Time interval is given, so you have to calculate initial separation. Okay, get the diagram now. It's there in Pathfinder. I just picked up. Just what all we discussed now. Just I'm trying to conclude using this particular question. Pathfinder, build up your understanding. Question number 27. Now, today I'll give some good number of questions from Pathfinder. So try to work out them.
Based on relative concepts, relative.
Yeah, you see the question is based on relative only.
No, sir, assignment question.
Yeah, based on relative motion only I'll give it. Get the diagram. First get the diagram, then write the equation. Okay, the diagram will be look at now. So this will be the velocity u1 is saying acceleration a1. There's a one best question. So where you'll get that idea of how to substitute the sign. This is something very important. Let the separation be between them. Let it be d. So let it be positive. Yeah, okay. Let me show the thing. Some of you give the answer. Okay, good. Okay, we'll continue now. So this is what happens at t equals 0. The situation is what? T equals 0. Is asking to get expression for d in terms of delta t and the given values of what? u1, u2, a1, a2, all that one. So I think there's no other way. Just we have to stick on to the basic formula, no? The first equation what you write is what? There is a concept, so you can manage everything. So again, the formula will be S12 final, S12 initial u12 t plus. Earlier we took A, B. Now the particles 1 and 2 are there. The symbols will change here. The final separation. So when they meet, what when the separation will be 0. So particle 2 is ahead of particle. So you write it, no problem. Position of particle. Let's do one thing. Towards right, directed positive. So plus u1 minus u2. Look at now, the sign for a1 will be minus a1. Minus a1 minus of plus a2. I want you to really make observation. What type of motion the particle 1 will describe? Retarding motion. What is it? What type of motion the particle 2 will describe? It's also retarding motion. But you see minus a1, okay, fine, we'll feel happy, no? As a retarding motion, particle 1, negative sign. Look at plus a2. These are the things which I want you to make observation here. This minus plus, is it sign for acceleration retardation or direction? It's for direction. So irrespective of acceleration or retardation, anything directed towards right, positive, anything directed towards left, negative. The retardation was directed towards right. So therefore, the retardation is positive. We are not substituting sign for retardation. Please do make observation. This is the concept. Just only to reflect this idea is what this question I picked up, nothing else. So this will be minus of, let me take this is reference, the position, this is reference origin. So you can take this is origin. This will be plus D. U plus U2T minus of A1 plus A2 T square by 2. So this will be A1 plus A2 T square by 2 plus D. This is D, not A. Solve this quadratic equation, you get 2 times, then the difference of that is what? Delta T, then we'll get the required answer. Please look here. This is something very important. Let me solve it. It's a quadratic, it's a theoretical one. Just only that particular accelerations has to be taken care, no? So this will be T is equal to U1 plus
Sir,
U2.
you can take directly difference of roots as discriminant by quotient of
Any mathematical method, no problem. Any mathematical method. B square minus of 4 A1 plus A2 minus 4 AC divided by 2A. So 2 into A1 plus A2 whole divided by 2. Solving this, we'll get the 2 times. This let me simplify one more step. U1 plus E2 plus or minus whole square. This will be 2D A1 plus A2 by, I think there are definitely 2 times are there, no? Here only you can see it. One time is, I'll take it first, -1. The other time will be the positive one. What is this
There it
T?
is minus 2d, sir, in T2.
Oh, yeah, this one. What is delta T? Delta T is what? T2 minus T1. That was a given thing. Then we'll solve for the D. What is the delta T given? Delta T is what? T2 minus T1. I think this U1 plus U2, that will get eliminated. So this will be root of U1 plus U2 whole square minus 2D. Shall I write directly this much? Solve for now equation for this. Squaring and adding. This will be A1 plus A2 whole square delta T square by 4. D is equal to U1 plus U2 whole square. Okay, this will be our final answer. Twice they'll meet. Out the path. Anybody just path, because twice they'll meet. This is our final answer. How do we can go for path? Let's go back to the basic diagram, the initial. Yeah, how one is moving towards right, undergoing retardation. Two is moving towards left and undergoing retardation. So how the path can be? This path is what we have to predict. And how it is possible, how they can meet twice? I'll draw the diagram. So first we'll show the path of 1 and path of 2. Please do analyze with the diagram. It will be really useful for you. So initially, this is the position. So 1, what happened, will go like this. Will do like this. So this is U1 and A1. This for particle 1. Particle 2 is here, no? What about the path of the particle 2? Particle 2 should undergo, it will also undergo retardation. And will be. So there's a rough diagram which I'm showing here. So where do they'll meet? They'll meet twice here, no? So there's a one meeting point. There's a one meeting point. Are you getting no this one? Then again, there's another meeting point. Some dark color. Just have a rough idea, rather than just only mathematical way of ending things, no? Okay, twice. This is what happens here. Okay, this is what here it will have velocity, say v1. when they're crossing, it will have velocity v1. Here it will have velocity v2. v1 dash, v2 dash, will write it. Particle. Similarly, the particle, when it is crossing here, it will have velocity v1 double dash, v2 double dash. Are you able to make it out? I can ask you many questions here also. What is the distance moved by the particle 1 between two meetings? Is asking this distance, this one, like this. Then how much of distance the particle 2 will move between two meetings? Is asking this distance, overall path. Can be asked. So once after getting the answer no, come back and analyze, oh, what actually going on here. This dotted lines, I'm just showing it here. So only twice that they can meet. This I'll write time t1, t1, t2. This is t2. Okay, all of you. So what all we just studied, no? So that what the condition is what we have here. Huh?